Morning, Chris.
Good morning.
Morning, Chris.
Hey, Bob.
How you doing?
Doing well. How about yourself?
Good, thanks.
Okay, well, it's 10 o'clock. I'm going to start the meeting, Bob. So thank you for joining us today. Today's, again, one of our Tech Talk Tuesdays, the series that Rexel's been putting on since the pandemic. We're, again, looking for topics. So if there's something that anyone who's on the call or would like to see or have us present, we welcome that. Again, this is really the new way of doing business today in today's world. We understand that. We do recommend that if you're not already connected to us through our website at rexelusa.com, that you do register there. You can get almost all the information you need online. And again, it's a great tool. Before you actually could call us, it's a good place to go and get information. We're excited today to actually have a good topic. I feel that is of very interest to a lot of our customers, and that's really industrial components and again, panels and sense electrical panels, how to optimize with the essentials, and some of that is on the screen you see right now. And normally we would have had our specialist, Matt Barton, present, but Matt is off this week. And pinch hitting today for Matt is Bob Cushman. Bob is a 35-year veteran of Rockwell. We were just talking about it. So I don't think you're going to have anyone that I've met with Rockwell with that many years. And some things get better with age, right? Right, Bob?
Absolutely.
But some housekeeping, just to inform everybody, we are recording this, and would ask that you mute yourself. If not, I'll mute you. If you have any questions in particular, you can put it in the chat or wait to the end, and we'll follow up with you individually afterwards. Either Matt, Chris, or myself, or Bob are welcome to do that. We just got a lot to cover today, and it'll be hard to stop and answer questions. And we're worried that we might go down a rabbit hole on some of the things that would take longer. But we're welcoming to follow up with you on any questions you might have. I recommend, again, you use the chat function and put that in there, and then we'll come back after and talk to you. So, Bob, with that, that's all I had. I'm going to turn it over to you and come back on at the end.
Okay, great. All right, welcome and good morning. Subject is panel optimization. The goal for today is to overview some ideas, concepts. This is all going to be done at a high level. And in the process, we may discuss some new products you're not aware of or unknown products. I think one of the things I always find is we have products out there that may have not, you may not have been exposed to for whatever reason. So this is a good time to do that. And John and I talked a little bit. What I'd like to do is follow up with folks via email, and maybe with some follow-up sessions. They could be virtual, over the phone. We could go into other topics in deeper depth, because there are some other things that affect the panel needs. And some of those are simple things like cost reduction, review, minimize the number of vendors. A lot of times when we're talking about a panel, there's a lot of products in there. And so when you have multiple vendors, a couple of things happen. You spend a lot of time doing research. You spend a lot of time cutting POs, and spend a lot of time, putting out separate bombs. So there's a lot of time that's spent and potentially wasted in the process as you look to multiple people to pull a solution together. So I think part of the goal too to look at here is there's the way to minimize some of that. And then the other thing is many times when somebody's looking at a new design for a machine or a panel, they're trying to future-proof it, meaning I'm going to design this, get it approved, and then we're not going to change this design for the next 5 years or 10 years. So I want to make sure that you've got the latest products, or at least products that we know they're going to be around, so that you don't have to go out and get it certified again. When you look at what does optimization mean, you know, to make as effective or useful as possible, to make it the best of. And as you'll notice, we've got on the left-hand side here, panel size reduction. And what we did is with these, a few letters here, acronyms, which we're famous for, we said, who would this be important to? Well, panel builders and OEMs care about how to reducing the panel. What about simplifying the wiring? Panel builders and OEMs. What about if we've got a panel and we've got to use the available I/O that's there to go ahead and provide the solution? Well, that's the OEM, but also system integrators care about that. And then
Hey,
what
Bob,
if, yes.
we got a guy saying he's got no audio. If you can respond in the chat, is everybody able to hear Bob except for Steve? Chris, you can hear him, right? Okay. Chris can hear fine. So I assume might be something with Steve.
Yeah, it might be the microphone, or it might be the speaker, you know, the way the speakers are set up.
Mm-hmm. Okay, continue, Bob. Hopefully Steve can resolve it, but from our end, looks like everybody else can hear.
Okay, great. And then the last one, that we've got some wiring systems that you can use to build a system and or migrate, and those would be important to system integrators who are trying to help a customer upgrade from maybe an older controller to a newer controller, or for end users and or OEMs. There may be times with some of the wiring systems, and we didn't talk about it here, but we'll see later that it may help with wiring a system and speeding up the production of a panel. So when we look at a panel, and I call it the anatomy of a control panel, because as we look at control panels, there's a lot of things that are similar between panels, meaning that, you know, they all have certain functionality that they need to make the panel work. And if we look at the panel from a big view, there's typically a feeder circuit. There's usually some branch circuits, and you'll notice here in color. And then there is usually some type of control circuit. Some cases that the control circuit could be relays. In this case, we're showing a controller and the associated products. And essentially, the basic goal when I talk to a customer about panels is they want to reduce the total cost and the time to build. And they also want to use quality components. I mean, a lot of folks, when they build a panel, it's very important how the panel looks and how long it lasts. I wanted to start off with the feeder circuit. You'll see it highlighted in red here. There's usually the in-feed conductors. Then we've got some kind of a disconnect on the upper right-hand corner. We usually have some way to distribute the power. You'll see the power distribution blocks. And we're also highlighting that there's the ability to use what's called a Busbar system to speed up the wiring. And so we're going to take a look at each one of these and maybe some ways to go ahead and optimize that. One of our products, a 194R disconnect, has a product for it that is called NFPA 79 compliant handle. The idea behind this, and if you look at the code, is that if a customer needed to open the panel under to go ahead and do some work, that they could turn the power off and turn the power on utilizing this red handle here. The goal is, we know that all too often, in the hurry to go ahead and do some work on a panel, that sometimes customers will grab a crescent wrench or lock jaws or a regular plier to turn the power on and off. This allows a customer to be inside the panel, utilizing that handle to turn it on and off in a safe manner. And if you'll notice in the code, it'll go through that. The other thing that we're trying to highlight here from an optimization standpoint is the fact that you don't need to worry so much about, well, you have to worry about alignment, but it's not as tight here because of the way that the handle mates with the front of the cabinet. So the goal here is just to expose you to this product, and then to talk about the fact that it might be a good way, if alignment's been an issue, of making it a little bit easier to put a panel together. The other option is we now have the 1494 universal disconnect. And with this idea, we have some flexibility in where the disconnect handle is mounted, because the cable is now the connection between the two. You still do have the ability to use a rod on this to go ahead and turn it on and off. The cable allows us to mount this handle on the right-hand side or the left-hand side. Certainly alignment is not that big of an issue. We've come out with a cable probably in the last 3 years that is highly flexible. Obviously, all of us understand the mechanics of pushing a wire through a plastic cable here. They've upgraded the cable so that it's much easier, requires less torque to go ahead and actuate the disconnect. And in the process here, we can minimize the panel space and the panel size by being able to have flexibility in where we mount the disconnect and the handle. The next step is power distribution. So there are a number of different ways to do this, from feed-through blocks that are open to blocks that provide UL 508 spacing, as well as a hinge on them to make them finger safe, all the way down to the enclosed units. Advantage here, obviously, is they are finger safe. But the other thing is you can now gang these together to get the solution that you need. So in and of itself, there's not really that much optimization on this page, other than to let you know there are options. Where the optimization might come in is in place of the power distribution block. You can use a multi-tap lug, as we're showing down here at the bottom, and connect that directly to, in this case, the circuit breaker that we're using. So this minimizes the need for a power distribution block. So we first of all cut down the space factor for the power distribution block, as well as the additional cost for that. So this is an idea on how to do some optimization in the panel. If we take a look now at the branch circuit, and you'll notice that's highlighted in yellow here, we're looking at the branch circuit protection, motor overloads, and the power to those units. So here's an idea utilizing a busbar system. The busbar system, this makes sense if you have anywhere between three starters or more in a system. There are a couple of really advantages to this. One of them is, you'll notice the person's hand here, this whole unit comes wired together. So all the wiring that you see between these units doesn't need to take place. This snaps onto the back of the bus bar. You'll notice these are the power bars here. And there is a cover form. So if you're not using all of the bus bar, you have the ability to cover it. I do have a customer that I worked with years ago. They build a lot of panels and they use a lot of starters. We sat down together and we were able to show an $80,000 a year savings in being able to use this system, just because of the wiring time that it took, the assembly of units, the mounting, and so on. So if you've got a number of starters in the unit, and by the way, you can connect drives to this and other things, this might be an option. This kind of looks at some of the advantages, right? You minimize the assembly time, the labor cost. Sometimes the assembly time is key just because I have some customers who say, you know, I could sell 20 machines a year, but we only have the time to build 17 machines because it's so labor intensive. So in some of those cases, this may be a solution. The other thing we minimize is the drilling for the hardware. We reduce quite a bit of the wiring. We've got a software system called MSS Star that we'll take a quick look at later that helps us lay this out. Temperature rise calculation to look at the temperature in the box. And certainly once you set this design in place, it now becomes, it now gives you the ability to use that over and over again. And you end up with panel space savings utilizing this. The other thing is reduced downtime for the end user, because when one of these starter unit goes, we just pop it off and replace it with a new one. We don't have to go and unwire all of it. We've obviously there are a couple of things we might have to pull the wires on, but the rest of it just slides right back on. This display here shows you that you can go ahead and extend it down to another rail utilizing this setup. The other thing that is key here is that because these are already pre-designed, these starters, they are been pre-tested to 65 kA. So one of the other things that becomes important here is that the short circuit current rating that you need to determine in the panel, certainly Busbar systems help with that. And this is the MCS Star configuration software. You'll notice that we go through the panel. It helps us lay it out. All right. And it allows us to go through and look at the temperature calculations. And there are some documents that help walk through this type of solution if it would be of an advantage to you. When we start to look at starters, many times customers will wire these together. We do have certainly the solution here with this Echo connection that makes the wiring quick between these, if that's something that you wanted to do yourself, or you could buy unit pre-wired. I know sometimes customers like to buy a number of components and keep them in the tool crib and then assemble the units they need for the specific machine that they're working on. And this is, you'll see when they're wired, when these are wired together, they're stiff enough to drop this on to the DIN rail. In this unit, if we wanted to, we also have the flexible wiring where each unit would be mounted to its own DIN rail and then wired together with the flexibility here of this flexible wire, so that we don't have the units, out of alignment, or maybe the DIN rail is a little bit lower. So this helps in those types of situations and prevents cutting and stripping and wiring each wire separately. So here's another idea on pulling the units together and wiring them together. We have this compact bus bar. It allows us to bring power in and then to go ahead with wiring that to this power strip here. We now can go ahead and connect multiple units to it without all the wiring time that it would typically take. We also then have the connection modules we talked about before to allow the connection to the bottom. This also gives us the flexibility of adding the auxiliary contacts, and we've got the ability to do a lockable knob on the front end. So a lot of flexibility here in a small system. And when we tie this all together, we can get it to meet the UL 49 branch protection that's required in a lot of applications. So here is a multi-motor application. To the left, you notice this is the way we typically would wire. It is very wire intensive and very time intensive to wire those together. We have the ability, NEC allows us to do one branch circuit for many starters and multiple motors. And all the way to the right, we've optimized that even more by using the 100K feeder. These are the smaller units. The 100K is a smaller version below the 100C units. So notice the wiring here, the minimized amount of wire that needs to be cut and stripped. We just take the compact bus bar and wire it into these units. The 100K contactor is our smallest footprint. It's typically used for multi-motor installations of 1 horsepower or less. So this is great for the smaller machines where you might be utilizing smaller motors. This is just an example showing, looking at the optimization to see how did we optimize the panels. If we look to the left here, or we look, I'm sorry, all the way to the right, we'll notice this is a typical wiring setup. Disconnect with the handle to a power distribution block, and then wiring to each one of the starter units. If we look to the left, we'll notice that this was optimized using an NFPA 79 handle to make the closure easier. We're still utilizing a power distribution block here, but now we've stepped down to a MCS bus bar system. In this example, just because there was a lack of space, you probably wouldn't use the bus bar system for 2 starters. Remember I said 3 or 4 is when it starts to optimize itself. But this just gives you the example of that. That is something that can be included in a system or a setup where there may be separate starters or separate connections that are not tied into the bus bar system. If we look at the middle application, we'll see a molded case circuit breaker with a multi-tap lugs. Notice that we have the ability from here to tap off lower power, right? So we're going to probably pull 120 volts off of here to go ahead and wire into an application. Just doing the multi-tap. So we eliminate this space and the cost. When we come down to look at the units, we are utilizing a compact bus bar that we showed before, along with the Echo module accessories in here. So some optimization and obviously the savings in time. The best way to go through this for your application would be for us to sit down and look at what it is, what the machine looks like, and then start to do some calculations. Because as I go through this right now, you know, a lot of times it sounds like this is faster, it's better, it's less. And that doesn't mean anything until we really say, well, what is your cost per hour? How quick, what do you use to go ahead and look at the time it takes to insert a wire? How many wires are we inserting? How many wires will we minimize? If we're using a system like this, will we minimize some troubleshooting that we may need to do? So all of those things need to be taken into account and calculated to do a return on investment. So now we're going to take a look at the control circuit. We've looked at how do we optimize the feeder? How do we then optimize what's in here from a branch perspective? We'll now take a look at if we're going to tap off and provide power to the controller. Notice typically we're going to do some type of a methodology here. In this case, we've tapped off the the power side so that we can keep the controller going even when the main disconnect is shut off, so that we can either do some troubleshooting, programming, updating of this unit with power removed from the device. And then we will go ahead and supply power, may go through a transformer, may go through a power supply to get to the control unit. So when we look at integrated architecture, we'll notice that there are a lot of different things tied together. And one of the things that we try to do when we look at the control side is break it down into 4 different categories. We've got supply, the supply of power. We've got the protection that could be provided by miniature circuit breakers or surge and filter components. Many times we don't talk about surge and filter, but obviously they can have a huge impact on customers and their systems, and the downtime that's associated with an overload and damage to the units. We've got a number, and number 3 here, we've got a number of products that will help us convert from different types of voltage or incoming signals. And then to the right, some different methodologies for connecting devices. We also have this concept called connected components. You may have heard of it. The connected components are really focused on a smaller machine where instead of using a control Logix or a compact Logix, you might use one of the smaller controllers like a micro Logix, or maybe you even have a system where you're not utilizing a controller at all. You're utilizing some relay technology with some potential push buttons and so on from the front. So in this situation, a lot of the same things apply from a supply, protect, convert, and connect. And in number 5 here, we talk about command utilizing push buttons and selector switch stations. And then the last one is indication. You know, many times the indication could be on a panel view, but sometimes on machine we'll end up utilizing stack lights or a big panel view display screen to let the end user customer know the status of the machine, the production of the machine, and so on. So when we take a look at this, we're going to talk first about supply. And the goal here is to have reliable and cost-effective power to be utilized by the control panel. And you'll notice here, we talk about multiple things in this section. When we talk about supply, we supply the computer, the controller, networks in there, and then obviously the I/O devices that are connected to them. So when we talk about power supply, a couple things. One of them does, the term does size matter, and certainly it does with power supplies. Is performance important? Yes, it is. And what about life expectancy? That's key from, if you're a machine builder, it's key from a warranty perspective and a longevity of the machine perspective, but also for the end user, it's a huge thing because if the power supply goes down, we end up with downtime, and certainly the number one thing in any production plant is typically safety, and then secondly is production and uptime. So when we look at the power supply, typically what a customer will do is they'll oversize the power supply for the panel. That does a couple things. It increases the cost of the power supply typically, and it'll increase the size in the panel as well as the heat dissipation. In this discussion, we're talking about one of our efficiency power supplies. It's got a steady state at current of 10 amps, but it has surge up to 150% for 5 seconds. That gets us to 15 amps. So this will allow us to ride through those applications where your machine would shut down if you utilized a smaller power supply. And so this allows you to really optimize the application. So notice at the bottom, a 20 amp power supply is 50% more expensive. It's larger and provides more heat than a 10 amp. The other thing that happens is if your incoming power needs to be stepped down, you also need to increase the size of the transformer. So you need to oversize the transformer to handle the higher inrush. The larger transformer means more cost, more panel space, and more heat. So you look at the bottom here, and with the utilizing the high efficiency power supply, we're able to use a 300 volt amp transformer versus a 500 volt amp with the other power supply used. So this does have a cascading effect when it comes to the cost, the heat, and the size on the power supply that's used. So in this case, we talk about the fact that it's almost 40% more cost for the larger transformer. Here's something that I think is really key. If you look at a couple of different power supplies here, we utilize the heat indication here. You'll notice that on a low or inexpensive power supply that the efficiency is at 84%. Heat loss is 32 watts. You see a lot of heat. And again, these are like little hair dryers running inside the unit with just pumping heat into the panel. This unit here is a little bit more efficient, 91%, but it still has heat loss. If you look at the higher efficiency unit, the efficiency is at 93% and the heat loss is at 18 watts. So you get a huge difference in the way this is set up. This also talks about the amount of heat in the cabinet. A 10-degree C temperature rise drops the life of the capacitor by 50%. So we know heat kills, especially when it comes to a control panel. And so the goal is to keep this as low as we can so the components last as long as possible. We also know that the heat in the panel, for any of the end users who've had panels for a while, the heat begins to degrade the conductor cables. The plastic on them starts to degrade quickly with the heat, as well as a lot of the plastic components start to degrade. So lower energy, smaller panel, longer life for the products, the components. This just shows that we utilize the smaller panel because of a smaller power supply and a smaller transformer. So we were able to optimize. And it just reviews here 50% savings on the power supply cost, 39% savings on the transformer, and then the high efficiency that's brought along with it. So now when we start to look at how do we protect the devices, this is an area sometimes where I see the design being not correct, meaning the 1489 is designed for branch applications. The 1492 SPM is designed for for loads in the unit itself, not for branch protection. Many times I'll see customers using the 1492 across the board. Primarily they look the same, and the 1492 is a lower cost unit. You'll notice here, if you look at the top of the 1492, it does not have any fins. The 1489 does. And what that does is provides a separation between the units. So now we end up with the ability to use this product in proper applications. I have had customers come to me and say that the UL inspector has denied 1492, that it was done incorrectly. I've even had some inspectors, and I think we may all have run into this, will say that the 1492 doesn't work. They'll start to question it, and they'll ask for all 1489, and sometimes they may not have the knowledge, or they're just trying to cover it. So I do have some customers who buy 1489 across the board for two reasons. One of them is they don't want the installers to install the wrong product. And then secondly, they don't want to run into the issues with the UL inspector, because we know what the UL inspector doesn't matter if you're right, if it's preventing the startup of a machine and arguing back and forth. So just a little comment here on circuit protection. The other thing we want to note is that for the 1489, the branch protection, that we do have circuit breaker bus bars. You'll notice that this allows us to mount to all these circuit breakers without stripping wire for each one. Incoming power is then distributed across all of the miniature circuit breakers. I guess the thing here I wanted to point out, you can notice here the 1489 has a space separation so that we can meet the code. And that's what'll tell you the difference between the 1489 breaker and a 1492 supplemental breaker. One of the things that is inherently part of a power supply, a switch mode power supply, is that it's self-protecting. And what it tries to do is to protect the power supply itself. So what'll happen in the event of an overload is the power supply shuts itself down. If I could show you right now what happens is when the power drops, the voltage is reduced, the current increases for a short period of time, and then it drops out. So when the voltage drops below a nominal value, then the whole system shuts down. This is an example of an application where the customer has connected the power supply through fuses to an indicator light, a sensor, a display, and a drive. And you'll notice over here the amount of current that's used under normal situations is 9 amps. When the fuse trips, the value is higher, and you'll notice the fuse value here. The expectation here is obviously that only one of these products is going to fail at a time. And in this application here, we're showing that the first 3 devices are functioning properly, but the drive had a short, which drives the current to 16.3 amps. The power supply tries to protect itself and it shuts down. So one of the things that happens in a plant, as you can imagine, is the maintenance person opens the panel, sees the red light on the power supply, goes and to the tool crib and pulls a power supply, or has one ordered, and has their local Rexel provider provide them the power supply as quickly as possible. And now it's installed, and when the unit is rewired and powered up again, and we don't know how much time we've lost, but we have a downtime now and a lost production. They powered up only to find that it was a shorted drive, but to find that shorted drive, they have to go unwire each one of these from the unit itself and test it. So a lot of wasted time here. We have a solution called a 1694. And so what that'll allow us to do is go ahead and determine where the issue is. And notice here it talks about a smaller power supply. Certainly you could put in a larger power supply here, but that may not be an advantage either, because you're providing power to some of the units while the drive itself is off, and you may want to remove power from the entire unit. It all depends on how you have the application designed. So if we take a look at the 1694 module, it connects to a power supply. The power supply then has a separate output for each one of the loads. And there is no current reserve needed. What will happen is if one of these units trips, the other units will stay green. The customer can quickly determine which unit has failed. All right, so this is a very efficient way to not install fuses and to find out which unit is tripped. I know that one of the other things that I hear about sometimes is that when machines are shipped, and this is the whole argument between fuses and circuit breakers, is if you ship them to countries where they may not have the replacement fuses readily available, there's a lot of downtime. Certainly this prevents that situation from occurring, because the trip is done through the unit itself. This is the, I'll take a look. If anybody's been around for a while, we used to have a family called the 1692 electronic fuses. The new family is the 1694. Each one of these units is separately orderable. It also has LED indicators on it, different sizes, current sizes depending on the application, and these can be all built together. Many times the question is there an adjustable, and in this situation there isn't, and the reason is we don't want the end customer to go in and be able to increase the power on the unit itself, the current on it, and essentially override the function of it. So in this case, they're fixed. In the future, we'll have the ability with the IO link connected to this to be able to have an adjustable unit. What the idea behind the IO link is that only the designer and the programmer will be able to go ahead and change that, and there will not be the ability for somebody on the floor with a screwdriver to, if they're getting the trips, to just increase the current, because obviously that's not the right way to run the system. So an electronic fuse, another way of wiring your system. The other thing is class 2. We almost all have a class 2 device in our house. It's the transformer for our doorbell. It's designed to be 100 watts or less. It's designed to be safe, so that we don't have a fire or we don't cause electrocution. Now, almost every sensor that's out there today has been moved to a class 2 device. Most of us don't even realize that. The idea being that the protection to that sensor happens on the front end through some type of a class 2 power supply. All right, so in theory, you need to have a class 2 power supply for your sensors. There are other loads, and in some applications, there's class 2 power supply is needed for specific safety applications. I know right now on one of our drives with safe torque off that it does need a class 2 to meet the safety requirement. So there's another way to go ahead and protect these devices. Instead of using a bunch of separate class 2 power supplies, you can use a 1694. This is the older version. I didn't change it up here, but this would be 1694. The newer unit can go ahead and handle multiple class 2 loads utilizing a standard power supply. So the cost of a class 2 power supply starts to add up. You can add a 10 amp or 20 amp supply and then let the 1694 break that down into the voltage needed and the current needed. We look at convert here. One of the things that sometimes happens is we're trying to.
We're down to around 15 minutes left. Just want to give you a heads up. So,
all right.
And 10:45. So okay.
Perfect. Thank you. Sometimes we're stuck with a situation where, in this case, this unit here has 0 to 10 volts DC, and the signaling device coming into it is 4 to 20. So, a couple ways to do this is we'd have to go out and buy another I/O module if that was available, or we could add a signal converter to go ahead and help us with that. So there's some other things that happen with the signal converter is we now eliminate any voltage drop that we typically would find. We're going to get some better immunity in the unit itself. And we could also go ahead, in this case, detect a broken wire because we're at 0 milliamps. So just the way to convert, if we take a look at the unit here, the family of those devices is 1931. And in this case, it converts from 4 to 20 milliamps to 0 to 10. And I like to highlight this as well because many times customers don't realize that we have a bunch of signaling devices. This is a new family that just came out in the last couple of months. It's called the Nano. You'll notice that they're very thin. They're a little bit higher than the other ones, but it allows us to go ahead and put a lot on a DIN rail. And you'll notice some of the things here: isolation of signal, convert or reproduce the signal to several devices, amplify the signal, take it and linearize the signal, split the signal into more outputs. All right. These also help with the issue with transients and noise. Eliminates the ground loops that we run into. Allows us to have the proper matching between the device and the field, like we talked about before. Prevents signal degradation. In some cases, we're running some expensive wires from thermocouples and so on back to the unit. This is a way to eliminate that. All right, so there's a lot of advantages to utilizing the product. You'll notice here a lot of the things I spoke about: analog current, bipolar signals, thermocouple signals, RTDs, all right, linear resistance, potentiometers. So the other thing I think that's important to note is some of you build machines that may ship outside the country. These meet a lot of the certifications that we're looking for. Interposing relays, we use these every day. Obviously, the advantage to them is they allow us to provide a lot of, a differentiating current and power to our load. What we wanted to highlight here is that we're utilizing an interposing relay that would sit on the DIN rail inside the cabinet. So here is our 700 HL relay. Notice that these are mounted next to each other like a terminal block. They've got surge protection, DIN rail mounted. They come in screw clamp or spring clamp. So obviously, if you're not aware of these and it fits the 6 amp for single and 10 amp for the unit, if it meets the need, it's maybe an easier way to go ahead and mount these without taking up a lot of panel space. And obviously the heat's that associated with a number of separate relays. So the last thing we're looking at here is the connect. The traditional method, obviously, we're all used to. We supply custom power to each one of these. Very typically, we use center jumpers. So we've got the center jumpers, which allow us to tie a bunch of these together. 50% reduction in rail space. So we minimize the number of blocks because of the way this is designed. So jumper bars become very important. One of the other things that customers, not all customers use, because there are a lot of customers that use just screw type terminal blocks, but there are these spring clamps, and now we have a push-in terminal block. The spring clamp is great, and the push-in terminal blocks are great for applications where there's a lot of vibration, because over time the application actually, or the wiring gets tighter because the vibration causes the clamp to clamp down, or the spring clamp to clamp down even a little tighter. So it eliminates the need to go in and retighten all the screws, retighten the screws before you ship it, and then retighten the screws again when you're in the commissioning process. This just shows how the clamp is held down. In the case of the spring clamps, you've got to insert a plastic device or a small screwdriver to slide it in. In the case of the push-in terminal blocks, we have two ways of handling that. One of them is with a ferrule that you mount on the end. The other one is with solid wire. If you are going to use stranded wire, you can do that with the push-in terminal block, but you do then need to use the plastic insert device or a screwdriver to allow those to get inserted. Now, notice the reduction in wiring time by at least 50%. The plastic actuators we talked about, safe way of pulling it out. There's no touching live metal wires. More and more customers are starting to go to the spring clamps, and we're noticing more customers are starting to go to the ferrule. Rexel does have a through Panduit has the ferrules. They also have a device, and for all of us that are enamored with mechanical devices, they have one that will strip and insert the ferrule all at one time. And it's one of those things that you just kind of put the wires in. You don't have to strip them, and you watch it do that. It's kind of like, I'm just going to tell you, for me being a mechanical guy associated with that, I stand there and keep trying to look at how it's doing it. So it's a very fast way to wire those up. This is the catalog number for the push-in. It's a 1492P. So you notice it utilizes the jumper, the plastic actuator, and so on. One of the things that's a huge advantage to it is that we've got these power distribution blocks. You can fit many, many wires in here to wire to the rest of the units and save lots and lots of space in the panel. So that's something new that's exclusive to the push-in terminal block product. We also have application-specific terminal blocks, in this case for sensors, that make the wiring easier. The connections are already in there. This wiring system is a very unique product, and this is the type of a product that really fits in a couple of categories. One of them is in a situation where you're trying to you've got a lot of cabinets to build. This allows you to wire incoming to one side of this terminal block here, and then there's a connector cable that snaps onto the I/O module. So you'll notice here several different types of these terminal block connector units. They have surge protection in them. You can buy them with fuses. You can buy them in all different types. And this is the connector that this unit right here connects to the other side of this. And then this goes to the I/O module. I have a number of customers who said this thing, they love these specifically in applications where they're using 32.0 because wiring errors occur all the time. And this just saves all the troubleshooting time. This just shows the unit, the way it's wired in the panel. I don't have a slide here, but for any of you out there who are converting over from a PLC 5 or an SLC 500 to the newer compact logics, we've got a whole system set up that allows you to utilize the existing I/O wiring and switch over the whole unit from the older controller to the newer controller. If you've got time limits like a weekend, you're shut down on a weekend and you got a couple days to switch this all over. You can just imagine the amount of errors that you might get into when you're rewiring all of the I/O modules. So there's a way to do that. I don't have it displayed here, but that's certainly information I can get you if you're interested. So instead of what routing on the left-hand side, each one of the wires to the terminal blocks below, you'll notice on the right-hand side, it's the one big wire that goes through there down to the interfacing module. Now, this is, it looks like it's not true, but it is. You look at the time it takes to strip the wires, cut the wires, put the wires in by hand and screw them in, versus the amount of time if you're using this system. You'll notice 46 minutes at the top and a minute at the bottom, because essentially all you're doing is snapping that on the DIN rail and then snapping the connector wire on the right and wiring that all the way to the unit on top. Very, very fast. So as we're coming down here to the end, I wanted to make you aware, if you haven't seen it, there are a lot of free electronic tools. ProposalWorks, we've added more and more wizards to that. Hazardous location wizards, wizards to help from a safety standpoint. It allows you to put a BOM together to go ahead and in fact, it's set up so that you can develop BOMs by customer types or by panel types. So then you can save them and use them again. Anybody that's utilizing or designing compact logics, control logics, integrated architecture builder allows you to do the overall system design and then dump that information into ProposalWorks so you can price it out. MCS Star is the software for the Busbar system along with the temperature rise calculation. And then if you go online, there's also short circuit current rating information for our product. So there's lots of different tools up there, and there's many that I've missed. If you want to find those and you've never been there before, it's as simple as going to Google and typing in Rock Automation product selection, and it'll take you to all those tools. The last thing that I wanted to say for follow-up is we talked about a lot of things today. This was very high level. If you'd like to specifically know about any of the products, or if you'd like to have us sit down and talk through your panel, and this can be everything from what products to utilize to short circuit current protection to, you know, does this meet the UL 508 code? Those are all different types of things that we can talk about. It's also a great time to have the discussion if you're designing a new machine, or if you're looking at a new panel design, or if you're, you know, any of those things. I need a smaller panel. I need a panel that's going to last for 10 years. I need a lower cost panel. I need a panel. I'd like to buy a panel from one vendor so that I'm not going and cutting 5 or 10 POs to different vendors and doing research on them. And I mean, the other advantage to utilizing this is that you've only got to make one phone call, right? You go to Rexel, and they'll help support you throughout the same thing. It's just like buying all your products from Home Depot when you're doing a build at home. You buy the plumbing, the electrical, the wood, the nails. There's one place to go back to when you need to get something fixed. So, and the last thing here is we've been doing this via virtual reviews, and we can do that with you as well. So In closing here, I'd like to thank you for your time. Thanks for listening. And then I will follow up with any of the questions via email. And please reach out to your salesperson and or to one of the specialists or to John if you'd like to schedule something virtual. Thanks again for your time, and have an awesome 4th of July.
Man, I got to tell you, you're amazing. It's 11 o'clock. Perfect. Nothing in the chat right now, but I know we're taping this, and this will be available for anyone who is on that they want to go back. There was a lot there, Bob. I mean, you went through all the essential components. I learned a few things on some of the new tools. The STAR software was new to me. Also, I was very interested in how you can optimize not only saving time and money, but really saving space. I think that was pretty big. And then also heat, right? I mean, less heat is a good thing. Heat
well,
kills.
and I mean, the other thing that I think that's key is there's nothing worse than helping a customer. And this only comes down many times when we sit down is we may sit down and talk and find out that in a year, maybe a product's going to change or we're going to upgrade it. And it'd be nice to have that conversation with the customer to make sure we're working in the right direction, right?
Yeah, you're out in front of it, right?
Yeah.
Yeah.
So there's a lot of different things we can discuss.
This was great. Again, we're fortunate, your 35 years of experience with Rockwell. I appreciate it. You've seen it, done it all. And it shows. I mean, I was impressed with all the information. And thank you for your time. For those of you that are clients that are on, as Bob said, contact us, Rexel, if you have any interest in particular on any section or component, or the specialist or myself, and we have access to Bob. So again, thank you, and have a nice 4th of July, everybody. Thank you.
Thanks, guys. Bye-bye.
Thank you.